The data below show information on price in thousands of dollars, horsepower, and gas mileage for a random sample of vehicle models commonly sold in the United States. You will use this data for a practice problem. So we have price in thousands. We have price in thousands of dollars, horsepower and miles per gallon of these cars. And let's look at what we're asked to do. It says test the hypothesis that horsepower is a useful linear predictor of gas mileage. So horsepower X is going to be used to predict gas mileage Y. Be sure you check the necessary conditions for a hypothesis test. So before that, let's get our prediction equation. So we're going to ignore the price right now. We're going to put this in list 1 and this in list 2. Okay, and I actually put my horsepower in list 1. Excuse me, my price in list 1, my horsepower in list 2, and my miles per gallon in list 3. And that's fine because then I can use them all whenever I want. So we're going to compare horsepower to miles per gallon. So these will be my X and these will be my Y. So I'm going to go to Stat, calculate number 8, which was a linear regression A plus BX. Okay, I have in my list 2 is where my X's are. List 3 are where my Y's are. I don't have a frequency list. And I do want to store my equation. So I'm going to go to vars, yvars, function, y1. And we're going to calculate my data. Okay, so we have my equation, which you can write down on your notes. And also, if we wanted to graph it and just get a slight picture, we could go to stat plot, on, scatter plot. Make sure I'm doing list 2 to list 3, or wherever you actually put your data. And then I'm going to go to zoom. Oops, I'm going to go out of this. Zoom 9 for stat. Okay, so there's my cars. And there's my prediction line. Remember, the prediction line, the only point it has to go through is X bar, Y bar. Okay. And let's go back to the notes. So I wrote down my equation. The predicted miles per gallon. Okay, equation, the R squared, which says about 40.6% of the change in miles per gallon could be caused or explained, I shouldn't say caused, can be explained by horsepower. And I had this in list 2 and this in list 3. And then my R is negative 0.637, which is a fairly low R. With an R that low, I'd say maybe it is a moderate or moderate weak negative correlation. Okay. Now let's look at it. So we're assuming that really there's no correlation, and that any slope we see is just based off of sampling variability, and we just happened to pick some cars that appeared like the slope was going down. So our null hypothesis would be that the actual slope of that line is 0, and our alternate hypothesis in this case is that it's not 0, because we want to see if it's a useful predictor of gas mileage and if there's just any type of difference, because maybe horsepower would make it go up or horsepower would make it go down. And in this case, it looks like the more horsepower, the lower the gas mileage. But right now we're just looking for a difference. So we want to do a t-test for the slope of a line. So in order to do that, we need to check our conditions. So our first condition give it a moment, is the relationship between X and Y linear. Looking at a scatter plot and the residual plot. Okay, so let's go back here. For a scatter plot, yeah, it looks fairly linear. And if I were to do a residual plot, okay, I'm going to go to Stat, Edit. Because I stored my data in Y1, I can go over here to list 4 and go to second list, and I do have residuals. You may have to push down. So residuals are the differences between what we expect to get in the Y, like 36, and what we actually got it. So it would be 36 minus the predicted value at 36, or excuse me, if you plugged in 110, you'd get a predicted value. So it would be 36 minus the predicted value, and in this case it would be 4.653, so the predicted value must have been 40.653. And we go to stat plot. There's my equation saved in there with all the decimals. On. And we're going to go to residual, which is again just a scatter plot, but this time it's list 2 to list 4 where my residuals are. And I'm going to hit zoom. I always forget to go out first. Zoom 9. And you can see my scatter plot is fairly random. No discernible pattern. And that is what we just looked at. Okay, we looked at our scatter plot. Okay, reasonably linear. And the residual plot, while not perfect, the plots do not suggest severe violation of linear. So we looked at this. Now we need to go back and look at our NPP. So that's our next condition. The standard deviation of the response about the true line is the same everywhere. Okay, so let's go back to our line that we did before. All of these were about the same distance apart, so that works. And then the next condition, the response varies normally about the true regression line. And so what we want to do is we want to do a NPP of our residuals. And you do know how to do that, but if you did, okay, we can see here that it's fairly linear. And we'll talk about that in class today, why that matters. And then the last condition was at a random sample of vehicle models, and we're going to say yes. So we had 4 conditions and we checked them all. And so now we're going to go ahead and do step 3. Well, we need to find our critical value. And in order to do that, we need our degrees of freedom, which is n minus 2. Or in this case, we had 15 cars minus 2, so it's 13. We also need our standard error. And our standard error, or SB, it's also standard error of B, okay, is our slope, negative 0.0694, divided by our t-value, which I happen to know is negative 2.98, but let me show you how to get that. We can't do inverse t because we haven't been given a percentage like we are with a confidence interval, but remember that the t-value is the probability of getting a slope as big or bigger, and since it's negative this way it'd be less than, of getting a slope as big or bigger than negative 0.0694, assuming that the slope's actually supposed to be 0. And that's what we're going to find out is the probability of that t. And so we're going to go and do a test. So let's go to stat, tests, and it's a linear regression t-test. Okay, we have our x data in list 2 and our y data in list 3. In this case, I'm trying to see if it's not equal to. Okay, my regression equation is in y1, but we don't need to put it there. And we're going to hit calculate. And it goes ahead and it'll even fill out the regression equation for me down here, or the r and the r squared and all of that. It gives us our standard error like we did with Barbie Bungee. It gives us our slope. What we really want is the p-value and the t. Remember I said the t was negative 2.98. Well, this is y. And the probability of getting a value that extreme is 0.01, which makes sense because it's almost 3 standard deviations from the average. Let's write that stuff down. So we have a t-value of negative 2.98, which gives us a probability of 0.010 ... or more specifically 0.0106425. Now let's go ahead. Is the p-value less than alpha? Yes, it is. So I can reject the null hypothesis. The slope is equal to 0. Okay, and conclude. I hate accept the alternative. Let's just say conclude that the slope is different than 0. Okay, and at the and this is done at the 5% significance level. Okay, here's our conclude. That horsepower is a useful linear predictor of gas mileage. We can also do a confidence interval for that. So this is 5 steps, just in that the step 1, I didn't put at first glance, it appears, blah, blah, blah. So you would go ahead and make that 1, this 2, this 3, this 4, and this 5, and you'll see that in your worksheet today. And now for the confidence interval, we have our 4 steps. Okay, we're going to estimate the slope. And at first glance, it appears that the slope is not 0 because it's actually, or our prediction was, negative 0.0694. This first person's first step is claiming that they're going to do a t-interval. So that's the step. We already checked the requirements. Now we need the confidence interval. And we're going to use the calculator. We're going to go to stat tests again, go to linear regression t-interval, hit enter. Okay, x in 2, y in 3. We want a 95% confidence interval. Okay, calculate. And we are 95% confident, so the slope is in between these two values. Okay, it does the degrees of freedom and everything else for you. Let's go back to the notes. Okay, so I wrote that in, and I can say I'm 95% confident that a positive difference of 1 horsepower corresponds on average to a negative difference between negative 0.1197 miles per gallon and negative 0.0191 miles per gallon. Okay, lastly, let's just find and interpret a 95% confidence interval for the slope for predicting price from horsepower. So now we're going to use our first column of data and horsepower and see if it's reasonable and if explain why not. So we check the scatter plot, and it shows a fairly moderate slope. Okay. The residual plot, however, clearly shows a non-constant variation, and so it's not nice and scattered. Okay, it's starting to spread out. And notice that my NPP has a wave to it. So we couldn't actually do what we wanted to do, which would be to find a 95% confidence interval for slope using price and horsepower. See you tomorrow.